I'm David Hill. I'm with the JavaFX team from Oracle. I'm the person working with a very small group to make JavaFX run on Embedded. Before we get started, I need some information from you guys. Okay. How many of you consider yourselves embedded developers? Let's see a hand. Okay. How many of you are familiar with JavaFX? Raise your hand. Ooh, that's better than I had hoped. How many of you work from home? Oh, sorry. Not as lucky. Okay. We have several things to cover here today. Let's just talk about JavaFX first. Since most of you raised your hands, this is for the few who didn't. JavaFX is a rich graphical application framework with built-in support for animations and effects in the Java API. The important part of this, to a lot of people, is your development tool support. You can use NetBeans. You can use the recently announced Scene Builder. You can use all of your standard Java debugging tools because they just work. Another important feature is that we're targeting GPUs. Not all of the embedded boards have them, and we have software rendering fallback, but we are definitely targeting GPUs because that's where you get the real cool visual effects. Currently, FX is integrated with Java SE7. You download SE7, you got FX. And of course, this is the standard eye chart. You have to have one of these in every talk, I believe, showing you just some of the controls that are used in FX. FX is visually configurable, which is really kind of important, especially for branding, which, of course, in an embedded device is really quite important. This is the same rendering code, just with different CSS behind it. And this, by the way, is an example on the JavaFX tutorial site. So it's not something I whipped up overnight, thankfully. All right, that's FX on the desktop. Since so many of you raised your hands, clearly we're ready to move on. Let's talk about embedded. So where are my markets? Okay, where do I think that this FX embedded is headed towards? There's a lot of things out there, particularly in industrial automation, where a display screen that the engineer can push to release a flow control, or monitor the temperature, or have it flash, please run to the bunker. All of those things make sense on a graphical display and can be done with FX Embedded. Okay? This is on your already existing FX system that potentially maintains your industrial automation. Home automation. Most of you probably realize that in your house you have somewhere between 2 and a dozen computers. A lot of those don't have graphical displays now, like your wireless router, but they could. Now, I would be challenged probably by several of you in the audience to say, why in the heck would you need that? But that's not my job. It's the person who's selling this wireless router that needs to come up with a justification. I don't know, maybe it needs to have a slideshow, or maybe it needs to say, warning, you're in Oklahoma, there's a tornado coming. I don't know. There's those things like that. You know, I keep reading that the refrigerator needs a display device. Personally, I'm not sure I need one, but hey, if they put one on there, I'll be really impressed, especially if it's using my code. Medical devices is another possibility. There's a lot of medical devices out there that might monitor something, like your blood sugar or something like that. And you can aggregate this information, perhaps taking it from your insulin pump, taking it to a central control station that logs and monitors your response over time. That is something that is very visual, very easy for people to understand in a graph, and very difficult to understand in a chart of numbers, or in some devices that I've seen, one line with a number and maybe an abbreviation. Okay, so mostly what I'm saying is that I don't know what application this is going to go in, because that's really up to you guys to come up with a really neat application and hopefully sell it for good bucks. So what I'm not talking about today is a general purpose tablet, okay? Pretty much what I'm talking about is things that are hooked up to a power cord. And there's a lot of reasons. We just don't need to go into those right now. Okay. So what is FX Embedded? The important line on this slide is that it's a proper subset of JavaFX. We've seen graphical UIs in the past that when they took them down to the embedded or the mobile space, they had to make some, shall we say, severe compromises so that your development pattern, say, was swing on the desktop and was CDC controls on the mobile device. Two very different domains. You had to retrain your people. In the case of FX Embedded, we are a proper subset. We do exclude a few things. For example, we have no dependency on AWT and swing. And because of that, we can't support some of the wrappers that are designed to work with AWT and swing or SWT. And I mentioned that by doing this, this gives you your common development tools with NetBeans, Scene Builder, which if you haven't seen Scene Builder, you really should go check it out. It's available for download now. And of course, all of the debugging tools. Did I skip one? Nope. Here we go. So the real question is how do you get those pixels on the screen? And we're concentrating on hardware accelerated, but for a simpler system with less cost to you, the embedded developer, you can use a CPU that does not have graphics acceleration in the form of a GPU. Your trade-off, of course, is that price for the real lack of performance. It's significantly slower, but we do support software fallback. We're working and very close to supporting media platform decoders. So if your platform has GStreamer plugins for H.264, we should be able to use those, certainly by the time we release with SE8. So how do you interact with your users? Mouse and keyboard is so passé, but it's also the way most of us are used to dealing with it. Well, maybe not. I got a cell phone. I touch that all the time. But we do, when it's integrated properly into the Linux platform, work with touchscreens. And we do provide a built-in virtual keyboard. We have also made sure that our user controls are scalable down to QVGA size, which, if you're using a smaller screen, is important. Also of a real importance to most embedded developers is what's the footprint of all of this, okay? SE8's got a rather large footprint because it's got Corba and several other packages that I probably am not going to use in my application development. Well, SE Embedded, we're looking at a compact profile of around 10 meg. Added on top of that, JavaFX Core, which I'll explain a little bit more about what that is. We're looking at hitting around 6 meg. So for a 16 meg flash footprint, you'll have a very capable graphical user interface. By the way, for more information on how that SE Embedded compact profile works, later in the week, Thursday at 3:30, I believe it is, Bob Vendette talks more detail about this particular subject and details the compact 1, 2, all the way up profiles. So there will be optional footprint in addition to the core, which is most of the functionality. You will pay extra footprint for media. Charts is under debate right at the moment, and certainly WebView, which is not currently planned for our first SE8 release. So here's where I live, the porting layer. Most of you folks don't care, but I'm going to tell you why in a minute. You're glad about it. We have a very small porting layer. We need to provide a window manager where there is no window manager. We need to handle input from the input devices. We have to talk to the graphics drivers. We have to talk to the media decoders. And in the future, we need to provide web node, which is based on WebKit. So a large additional footprint. The important part to most of you is that last line. Most of the code is in common with the desktop, which means not only is it good for me because I don't have to work on that code most of the time, but it's good for you because the behavior that you see on the desktop on that Windows, Linux, or Mac platform is also likely to be the same behavior that you'll see here on the embedded device with a couple of constraints. Those constraints being how well the GPU, the hardware acceleration, supports some of those operations. I've alluded to this a couple of times. These are features in JavaFX that largely don't make sense, except maybe the web view, in an embedded environment. For example, the system menu support. This is support built into FX so that you can have a system menu that ties, for example, into the Mac toolbar, the one that goes at the top. Well, since I'm in a full screen application with or environment with no window manager other than me, I really don't know what system menus mean yet. So at least right now, that's out. Swing, I mentioned. Drag and drop is another one where someone needs to convince me that I really need to spend a lot of time there. And WebView. And the interesting thing about WebView is that because it's based on WebKit behind the curtains, it's a lot of additional work and a lot of additional footprint. So we're delaying that implementation, at least for now. Availability. You can get it as of last Sunday for download. This developer preview works on a BeagleBoard XM, which I'll talk about in a little bit later. But moving forward, we also have alpha and beta programs for interested partners. And if you are one of those interested partner wannabes, come talk to me afterwards and I'll direct you to the appropriate program manager who can talk to you. We also will be integrated in the SE8 embedded release, which is happening next year. Okay, let's talk about platforms for a little bit. In general, we're looking at a Linux kernel, we're looking at ARM, and depending on the application, as in your application, embedded application, integrated EGL, OpenGLS v2 support, integrated touch support, and if you want to use media, you'll also need to make sure that you have the integrated hardware decoders because they make a huge difference. When we first started this project, we knew we had limited resources and we wanted to pick a platform. And there's a lot of vendors out there, there's a lot of OS versions, and everyone has their favorite board. Believe me, we had this discussion. We picked, and many EGL drivers. Most of the vendors out there, for example, TI or Freescale, each have their own GPUs. And each of them have OpenGL drivers, and they vary in availability, compatibility, support for media drivers, and all the rest. After all of our decisions, we picked the Beagle XM, not because it was the fastest. We actually didn't want the fastest. Not because it was the slowest, because didn't want that either. But it had some of the sweet spot for us, okay? It had available drivers. It had the ability for those graphical drivers to write directly to the frame buffer, which isn't always available on some platforms. We are monitoring other platforms, okay? By monitoring, it means I get it, I beat it up a little bit, but QA doesn't spend a whole lot of time on it, okay? So we have our stuff running in-house on the Pi, on this Freescale IMX53, the Panda board, which, by the way, if you saw the kiosks around here, the scene builder, the schedule or kiosks that are out there, those were running on a Panda, okay? And I even have it running on an Atom. Okay, rendering paths. How do I get to the screen? We're looking at 3 rendering paths, and I'll dig down a little more deeply into what these are, okay? And for most of you, you may not care, because hopefully it'll just work for you. Our favorite rendering path is OpenGL. It's ES2, using EGL and talking directly to the frame buffer. The nice thing about this is you don't have the additional overhead of X11 and a window manager. So you not only aren't paying for flash footprint, but you're also not paying for memory and the extra time commitment of packets going back and forth between the different processes. This requires native driver support. The Panda, for example, currently doesn't do this. It's coming, it's coming. We've been told that for 2 months. Haven't seen it yet. The Beagle does it, the Raspberry Pi does it. In this particular case, since all you really have is a frame buffer, which is just a lot of bits on the screen, we need, as in me, I need to provide window management, because an FX application can have multiple stages, which translates into multiple windows. You also have pop-up menus, file chooser, menus, pop-down menus, pop-to-the-side menus. All of those are a window. Well, I have no window manager, so I have to be the window manager. I support to front, to back, moving, resizing. You don't have to be full screen if you want, but you can be. All the rest of the stuff that you would just expect to work really does. We read our input straight from dev input. Now, this is an intriguing thing to do. Most of the time, most developers don't have to worry about this because X does it for you. They've already done some of that work. We're still learning, but we currently read from mouse, keyboard, and at least a certain class of touch device. Apparently, there isn't quite a standard for touch yet, and so we're still understanding all of that. But you can see that we've gotten it at least to a certain extent because the schedule builders certainly seem to handle touch quite nicely. So we also have software fallback. We're using DirectFB to access the frame buffer, and that provides us with a basic level of window management and also our input support. This uses a non-Java 2D, a non-AWT rendering path. So this is our own path. And by dropping AWT, we are able to save quite a bit of both memory and flash footprint. It's much slower compared to EGL. In one test I saw just this morning, and Bob will show you later in the week if you go to his talk, one particular test, it was a factor of 50 different between the two. As in like 1 frame a second on an abuse test to 50 frames a second on the same abuse test. So the last rendering path is a reasonable rendering path, but it's not one we've been concentrating on up to this point. And that's using OpenGLES, EGL, and X11. Again, it requires an X11 server and a window manager, with the input managed by the X server. X11 does add several overhead and limitations to this operation. Not only is it memory, not only is it flash footprint, but there's certain operations the X server wasn't designed to do, like shaped windows. which is something that we handle in our EGL case quite easily. Okay? And a lot of the FX UI controls assume that that pop-up window has rounded borders, which is a shaped window. So there's extra overhead that X11 forces on us because of that. So as I said, it's not really a focus for us right now, and it's currently not planned to be in the SE8 embedded release. Media, I think I mentioned already, we rely on GStreamer, and our intent is to use any vendor-supplied GStreamer plugin. Okay, design considerations. My desktop app should just run, right? I get asked that a lot, constantly. And my response is, yeah, probably, as long as it avoids AWT, Swing, Media, and WebNode, at least at the moment. But will that application be usable? I've had several applications that assume that they have an HD display, and when I bring it up on something sub-HD, the application was written in such a way that it didn't rescale to use the available real estate. So all of a sudden, a big chunk of my controls are off the screen. Okay, that's not terribly usable. So this is just the tip of what I'm going to be talking about now. Okay. Embedded platforms. Mostly you're dealing with a slower CPU and GPU. As you guys probably know, this Beagle I have up here is running at around 850 megahertz. Raspberry Pi, somewhere around a gig. No, it's less than that. But still, we're talking about just the CPU. If it was truly a one-to-one with Intel, you know, you're looking at a CPU from, 10 years ago, something like that. Of course, the advantage of these is you're also using a lot less energy. You're also going to have less memory on these. This Beagle has 512 meg. I know I've seen boards out there in the gig range, but you know, they're not like my Mac here, which has got 4 gig and 2.2 gigahertz processor, I think it is. You're also likely to have a smaller display. Notice I say likely. It's not always the case. The Raspberry Pi will output in full HD. So that's some pretty decent real estate. It's also possible that you're going to be dealing with touchscreens. And touchscreens is a very, very different UI art. Okay? That button that you can click on with a mouse, you can't click on with your finger. Things need to be bigger. And depending on your use case, you may want all the rest of your controls to be bigger as well. Okay? So again, will it run? Could be, but not necessarily. You do, to a certain extent, have to target. Now, will you be able to take this off of the Beagle and run it on your desktop? Most certainly so, especially if your desktop's got a touchscreen on it. Other things to think about. Keep it simple if you can. Really complex scene graphs will slow down rendering. It adds to your computational load. And if you're trying to get a high frame rate, and with all of the FX bindings and stuff like that that are in there to make life easier for you, it really can slow things down. There is a toggle that you can enable caching, but remember when you do that, caching means you're stealing the memory that possibly you need for something else. Okay? Freeing up unused resources. This is another big bugaboo. In the demo that I'm going to show you here in a few minutes, that was the biggest concern. Our demo crew went whole hog, loading up large resources, and a lot of them, and were surprised when we ran out of memory. So after a couple of passes, we managed to come to a compromise that looked visually quite impressive, and you'll see that in a moment, but also would work on this more limited device. Other design consideration. effects. JavaFX has a lot of effects. Say that 10 times fast. All right. The cost of those visual effects will sometimes surprise you. Certain effects appear to be virtually free. Others are really, really expensive. And our team is still working on seeing if there's better ways we can do some of these effects. But in some of the cases, I don't think we will be able to. Okay? And this is largely because we're dealing with a 4-pipe GPU instead of a 100-pipe GPU that you might have on your desktop. It's all about bandwidth and the size and the capability of the processors involved. So play with them. Find out which ones work, find out which ones don't work, and plan accordingly. And here's just something to consider. I worked on a cell phone operating system a while back, and I had a really interesting crash. One of the managers took his 10-megapixel cell phone and went out and took a picture of his cat, I think it was, stuffed it into our cell phone and said, make that my icon. And our software was a little young at the time, and so it took that 12-megapixel image and made it his icon. And then they came to me and said, Dave, why is this contact page loading so slowly? And I was like, oh, Lord, here we go again. Okay? FX has the ability to load a thumbnail. Okay? So you can subset an image on the way in, something that I ended up having to write back in my cell phone days. Okay? So be aware of that feature and use it if you need to. If you're loading a texture, if you're loading an image that is not one of your own resources, you definitely should consider constraining it when you're loading. Other things to think about. I know in my case, I bought an embedded device called a cell phone here recently, and the first thing I did is bump the font text up because my eyes really appreciate that. Okay? And depending on your use case, you really might need larger text. And as I mentioned, bigger overall controls are often something that you see in embedded usage. All right, let's get to the demo. The first demo, I'm not even going to show you here because I want you guys to go play with it yourself. Rather than me stand up here and show you a canned set of routines, I want you to go try one of these kiosks out, log in as guests, and sit there and play with the scrolling. And remember, this is a demo on an early access at this point. But it still looks, at least from my perspective, really sweet, especially when you realize you're scrolling basically HD real estate, and it's doing it very fast and very smoothly. So there's your first demo. That wasn't painful, was it? At least not for me. Okay, this is another one that was cobbled together by our demo team. The idea behind this is that we wanted to come up with, again, a use case for how you might use embedded. So a lot of you have walked by those large, big printer scanner multifunction units that are ubiquitous in offices now. And you've probably used its control panel, and depending on your point of view, it was easy or not so easy to use. So this is going to be an imagination of how we could be doing this with JavaFX. And again, this is all written in FX, and it's running on this Beagle that's sitting up here. Okay? And again, the Beagle's running at about 850 megahertz. We have 512 meg of memory. This is GPU accelerated. All righty. And normally, this should be touchscreen. And if you go to the demo grounds, you can see the touchscreen version of this. All right. As a graphics guy, that scroll in blows me away. I don't know about you guys, but It really makes me happy. And see, we have controls here. And again, I probably would have made that a little bit bigger, but I wasn't on the demo team. Psst. Let go. Let go. There. Really? Let my mouse go. Ah, there we go. Okay. So, we're going to scan something. We give you some choices about how you could scan from the platen. And we have a quality level, for example, or black and white or photo. So we go to the next page. And here at a moment, kick on. Oh, hang on. That one, I forgot. I didn't boot the version that doesn't know about the scanner that I don't have here. Sorry. All right, same kind of thing. We have a color image. We have, notice the larger controls. And there we have it simulating, actually printing. All right, and let's go to storage. So here we have an animation that is prompting you to install your SD card or your memory stick. And then we have various files or images that we can store on the device. All right. And as I said, this is available in a touchscreen version over in the demo grounds. Please come visit us, and we can show you the full scanner path. So that's that demo. At this point, I'd like to show the required legal, oops, got to hit the button. So I can show you the required legal disclaimer, and then we can move on to Q&A. Any questions? Oh, come on.
Yeah, were those pictures in the animation, or was it real 3D?
That is not the 3D. That is all, it's done with FX, but not with the FX 3D package, which isn't part of the FX 2.2 Plus that we're currently working with right now. Yeah, go ahead.
Well, you mentioned that you support a special kind of class of touch devices. Which class of touch devices are those?
The class of touch device is more in how it integrates into the Linux kernel. And I didn't do that work directly myself, but it comes down to there's various ioctls that you can query to see what the features are of the touchscreen, and then how the data appears in dev input. And I'd have to go back to my touch guy to ask him the gory details of it. But the gist of it is that we had two touchscreens, one of which, once we had it integrated, the one that we have over in the demo grounds, that worked really well. And then when we tried to do another one, we found that that one spoke a different flavor of these ioctls. And so that's our frustration. We need to be able to detect and dynamically handle those. Okay? Other questions? Yeah?
Is there kind of a minimum set of resources you feel are needed to actually port JavaFX to a device?
Yes.
Thinking about Raspberry Pi, does it have enough resource actually to run it?
Yes, the Raspberry Pi certainly has enough resources. So the question was, what's the minimum set of resources? The minimum set of resources is Linux, our JVM, which right now we have to use the soft float on Raspberry Pi because that's what's publicly available. So the JVM, in addition to the JVM, I need the hardware acceleration, which the Pi certainly has. quite well, and we need access to dev input, which the Raspberry Pi works. There's a couple of questions in my mind on dev input, but it looks like it works really well too. So that's really kind of our initial minimum, and once we add media on top of that, then the question comes down to the GStreamer plugins. And as I recall, it's not my area of expertise, as I recall, the Pi does have that as well. Yeah.
So it really comes down to availability of the bindings to the hardware acceleration that allow you to run.
Right, yes. It does come down to the availability of that. So in our particular business, we're not going to be providing you with your OS. Most of what we're looking at is a vendor will be bringing to us a board with all of this stuff integrated on. And as long as it's properly integrated, we should be able to work very quickly with it. The only questions would be things like, the flavor of touch or something like that, which are usually easily handled. They're not that different, but they're different enough that it causes me great headaches. But the other issue is, again, the graphics drivers. A vendor's going to bring this to us, and if they want that EGL frame buffer, direct path, they're going to bring that to us. It's not something that we're going to do. And in the case of the Pi and in the case of the Beagle, that's there already. In the case of something like the Panda, that they claim they're working on it. So, good question. Okay. Yeah.
So, just like I said, you're writing for OpenGL.
Yes.
And you're assuming that they're doing all the work underneath.
Yes. So let me clarify. We're writing to OpenGL ES 2, not 1.1, 2. And which is not an unreasonable limitation in the current market of devices. And the reason I specify ES, of course, is because that's what you're going to find in an embedded system. And it has different performance characteristics compared to desktop GL and different capabilities, too. And so the FX team has written to the ES spec. For the most part, there's a couple of places where they take advantage of full GL that I can't. But yes, we just rely on opening up and driving bits through.
So if you have a platform that you do software rendering, and so long as you don't do a lot of animation and effects, it's probably okay.
Yes, so the question is if you're not doing a lot of animation and not a lot of effects, can the software fallback work? And I think the answer is yes. I think you're dealing with a relatively simple use case, but like if you were thinking of advertising signage or something like that without a lot of media in it, there's something that's moderately static. You certainly could use FX for the rendering because we have a lot of rich text capabilities in FX, and you could certainly do something like that. Of course, in that same industrial signage or advertising signage, with a little bit more processor, you also could add in media and text spinning in and, blurring text and, reflection and all the rest of those things. Okay? More questions? Yeah?
Well, the oldest platform you're currently supporting is ARM v5 with a headless JVM. Will JavaFX Embedded work on ARM v5? Because the Raspberry Pi is ARM v6.
I believe the Linux embedded for ARM that's available for download is only v6. Bob?
It actually runs on 5, 6, and 7, but I don't know if your FX drivers have been compiled for 4, 5, or not.
Right. Okay, so
The Raspberry Pi is 6, and our Jerry runs on it. As long as you use the soft FP distribution, we don't have our hardware available yet.
yeah. All right, just to summarize, it sounds like the JRE will support ARM v5, but right now we're not supporting headfull on it. So, but again, all of this comes down to, partner deals. The public release is targeted more for people to come check us out and see how things work. And hopefully for the hobbyist, once everyone gets a Beagle, or once we start supporting Headful on the Pi. But for a lot of those CPU details, attend Bob's talk on Thursday afternoon. More questions? Hearing none, I guess I'm done. Thank you very, very much for coming.